In this video I'm going to be covering acid-base titrations, and we'll be starting off with a question about weak acids dissociation constant and going on to buffer solution calculations. So firstly, we'll be starting with this one. Ethanoic acid is a weak acid with Ka dissociation constant equaling 1.76 times 10 to the minus 5. It says calculate the pH of an aqueous solution of ethanoic acid with concentration 0.22. So firstly, we'll be writing this equation down. So Ka equals HA times A minus over HA. And we have Ka initially as well. So we can substitute this in straight away. 0.76 times 10 to the minus 5 equals H plus times A minus over HA. And we also have the value of HA because it gives us the concentration of the acid here, which is just what HA stands for. So we can multiply this HA by the Ka here, 0.22 times 1.76 times 10 to the minus 5. This gives us a value of 3.87 times 10 to the minus 6. And this equals H plus times by A minus. And interestingly, because this is a pure concentration, it's just ethanoic acid, the dissociation equation actually looks like this, with the amount of HA being produced equaling the amount of H plus and A minus together. So these two are actually the same value because neither of them are reacting with anything. So we know that these two are the same, which means this can just be simplified to H plus squared. And so if we just square root 3.87 times 10 to the minus 6, we get a value for H, which is equal to 1.97 times 10 to the minus 3. And obviously so this is the concentration of H plus, and to find the pH, because it asks for the pH here, we can just minus log 1.97 times 10 to the minus 3, and this value is 2.7, and that seems about correct for a weak acid. Moving on to buffer solutions, calculating pH of a buffer solution. We have this question here. Buffers produced by mixing 100 centimeters cubed of ethanoic acid of concentration 0.8 with 50 centimeters cubed of aqueous sodium hydroxide of concentration 0.8 at a temperature of 298 Kelvin. So calculate the initial pH of aqueous sodium hydroxide. So we'll need to use this equation here, Kw. So the water constant equals H plus multiplied by OH. And this means that, so we can use the value for Kw, 10 to the minus 14, over OH equals H plus. And we can just substitute in OH. We can work this out simply by using the value of the concentration of sodium hydroxide. So 10 to the minus 14 over 0.8 equals H plus. So we get 1.25 times 10 to the minus 14, which is the concentration of H plus. We can just do minus log of this answer, and this will give us the pH. pH comes out as 13.9, which looks correct for a strong acid like sodium hydroxide. And it says calculate the pH of buffer solution. And this is interesting because there's actually two methods of doing this. There's a slow way and a fast way. I'll start with the slow way, and I'll show you the sort of trick to do it in about half the time. So no pun intended. So mixing 100 centimeters cubed of ethanoic acid, so we can do a calculation like this. 100 centimeters cubed minus 50 centimeters cubed, because this sodium hydroxide will be using up the ethanoic acid, equals 50 centimeters cubed. We're left with ethanoic acid because all the sodium hydroxide had been used up, and we can just do this 0.05 times, I think it was 0.8. Yeah, 0.8, which equals 0.04. And drawing out the equation here, we see that, so we're just going to draw this equation again. A minus plus H plus, and then we can see that half the amount of the initial HA has been used up, because we've got 0.8 mol dm concentration here, and we have 0.04 remaining. And because if we do this calculation over here, 0.8 times 0.1, we get the initial amount of moles, 0.08. We see this half the amount of moles remaining, 0.04. So if we look at this calculation here, HA, so the acid, will be left with half of this, so it's 0.08 minus 0.04, which is just 0.04. So these, we know these are both 0.04, not that, 0.04. So if we use this calculation here, Ka equals H plus times by A minus over HA, we see that because these are both 0.04, they cancel out. So we're just left with Ka equals H plus, and the Ka is 1.8 times 10 to the minus 5, and we just do minus log of this value to give us a pH, and this is just 4.7. And that took about probably 4 minutes to do that, but if you look at the question, there's actually a trick to do it extremely quickly. So it says here 100 centimeters cubed of ethanoic acid at a concentration 0.8 with 50 centimeters cubed at the same concentration, and this is something called the half equivalence point. And when you have an acid reacting with a base at this half equivalence point, it means half of the acid is being used up. Therefore, HA equals A minus. So we can therefore cancel these out in the equation every time, and therefore the equation simplifies down to pKa equals H plus, and pKa is just minus log of Ka. And that's how you'd be able to do this question in under 2 minutes to get these